If you know Bob the Builder, you know he's built a house or two. But the brain has built a house of its own, and it's known as the blood-brain barrier. This barrier is made up of blood vessels with special cells and proteins, all carefully regulating what gets into the brain and what stays out. The problem is that many potentially life-saving drugs and therapies can't get past the front door. But the key to unlocking that door may lie in understanding how the house was built in the first place. The blood-brain barrier first appears early in development, and at these stages is like a good chunk of UCSF's campus, under construction. By injecting a specific kind of dye into mice at these early ages and tracking how that dye gets into the brain, our lab and others have found these construction sites where new blood vessels are being built. In these sites, the barrier naturally allows certain things into the brain that it usually doesn't. We think that by understanding the blood vessels in these sites and how they differ from fully built blood vessels, we can design therapies that access the brain and be especially useful for diseases that need treatment before birth, when these sites might still be around. So what makes these construction sites so special? My research has found two critical differences in the blood-brain barrier as it's under construction. First, using a technique where we look at individual cells that make up the blood-brain barrier, a technique known as single-cell RNA sequencing, I found special types of cells that allow more things across the barrier. These cells are highly present in our construction sites. Second, blood vessels like to build on a foundation of a protein called collagen. And usually this collagen is sturdy, rigid, which makes sense when you're building a house. But by looking at slices of mouse brain at different ages, I found that in these sites, there's a different kind of collagen protein, one that's flexible and designed to bend and twist in ways that the typical protein simply can't. As we track these changes over time in the building blocks and the structural foundation of the blood-brain barrier, we're creating a blueprint that could change how we deliver things into the brain and potentially find similar areas in adult brains or neurodegenerative diseases. As we put together this blueprint, the real question becomes, can we build it? I think we can. Thanks.